Hello, I am Nick Ladensack. I did my project on acronym disambiguation using methods built off of the BERT model. Some of the problems and challenges I encountered while completing this project. First off was just figuring out how to use datasets and data loaders in PyTorch. I had to implement a custom dataset class, and within that class I had to kind of define some stuff. I had to override a couple of functions and just trying to get that figured out so I could use a data loader to batch my data for training. Took me a little bit. Wrapping my head around some of the function outputs for different things. For example, the BERT tokenizer outputs input IDs and attention masks and things like that for the BERT model to then use. And kind of wrapping my head around how the output's formatted, how I can access different pieces of it. It took some time, more than it probably should have, just due to kind of finding the documentation that made sense to me. Some of the general debugging for just getting the code to work and getting around some of the silly mistakes that people make from time to time. Things like I didn't have a couple of lines indented, so when I was going to run things, I would go back. I'd be going through and it would run into an error saying that this thing wasn't defined, even though I did define it, but I just didn't have it indented, so it wasn't included in the right spot. A couple of other issues came in the form of memory and time constraints. Memory became a huge issue in Google Colab, where I was running this, because I ran out of RAM in Google Colab when I went to do my training, so that pretty much brickwalled all progress from that point forward. And time constraints are pretty obvious for this project. We only had a couple weeks really to go into this project and trying to get something cohesive, especially modeling after what was done in a paper that usually had more than one person working on it, is very difficult to achieve to begin with. My motivation for choosing acronym disambiguation is because it's a challenging task in NLP. It's still being tackled in natural language processing as part of text preprocessing, especially for some of the other types of tasks out there. And I wanted to see how I might be able to leverage existing models like BERT to tackle the problem, or at least attempt to tackle the problem. I am currently working on a project at my job where I need to take in input and then map it to an output sequence, sort of like, hey, this is the problem we ran into, so can you give me the resolution to that problem? But our input data has a lot of acronyms and abbreviations mixed into it, so I was curious to kind of see how I could approach trying to disambiguate the acronyms before doing anything else with data like that text input for the project I'm working on at work. Some existing related approaches. Transfer learning is a huge one, and it's one leveraged in this paper and many others, especially off of BERT and BERT-based models like Roberta for CS-based areas. And you have BART, you have all these different models that leverage transfer learning, so you can take advantage of these massive models trained on multiple GPUs, on these massive corpuses, things that you and I couldn't run on our basic laptops and computers, but can be run on these massive systems that bigger companies like Google have access to. Leveraging some large labeled data sets that have been built up over time. Like if we have a large dictionary of acronyms and what they mean that we can pull from already that's been built up over time, that can help speed things up some with acronym disambiguation on new acronyms even sometimes. Storing and using some of the context. A couple of the papers I looked at specifically went into storing some of the context around where an acronym was used as a part of it, trying to piece together what a new acronym means when they encounter it. Like, oh, this has a similar context to this acronym, so this could be a better guess than maybe some other acronym with a completely different context around it. And another approach was the use of document embedding as opposed to just word embedding, which we see a lot with text processing, but document embedding. So we embed the context of the words in question that we want to look at as a part of it all. And doc2vec being an example from that's derivative of the ideas behind word2vec, for example. The method for this project was we would have our input, which we would have the classification token at the front, and we'd have a separator between the actual expansion of the acronym and the sentence that the acronym was used in. We'd have a start and an end token placed around where the acronym appears to help put some attention on it. And then we have a final separator token at the very end to denote the end of the sentence. We then would pass that into our BERT model. We would take out the classification head and information, which is used for a lot of downstream tasks in NLP. And we would take the mean of the positional vectors of the start and end of the acronym. We would concatenate those together and then run it through a few more layers, drop out another dense layer, ReLU, drop out dense, and then finally sigmoid, so we can get into our binary classification. My results, I didn't end up getting any at this point just because Google Colab would not allow me to, and I just didn't have the real time and resources to do this. The data set I'm using, I guess, is too much for my computer to handle. It's just staggering the amount you need for some of these tasks as well. Just being able to run this model on a downstream task is rough, even for something like Google Colab, although to be fair, it's somewhat limited without Colab Pro. And PyTorch, Transformers, a lot of these libraries that are out there give us access to such powerful tools for NLP. PyTorch and Transformers especially, since Transformers are such a powerful architecture in NLP, and they've been leveraged successfully for a while now. BERT being a strong example that implements Transformers, as well as all the other ones that have then derived from BERT originally. In conclusion, current NLP models are capable of a lot in terms of acronym disambiguation and other tasks, but they also involve a great deal of training on relevant data. Transfer learning with models like BERT have led to great results on cleaner data samples, especially. The problem really being that clean data is hard to get a hold of, labeled data hard to get a hold of, and even in my case, even with something like transfer learning, I still couldn't run the model because it was just too intense. Future work would include continuing to build on BERT and other models like it with the work of transfer learning. Definitely improving some access to clean and labeled data samples could allow for us to get further, and just access to stronger computational resources. If we could get around some of the computational constraints, we could really go so much further with machine learning as a whole, but especially with NLP for some of these intense tasks that even the state of the art still struggle with. Thank you.